Grouping method of solving linear P.D.E. ZP plus x is equals to 0. These are a linear P.D.E. of order 1. P tan x plus q tan y is equals to tan z. Again, a linear P.D.E. of order 1. P plus 3q is equals to 5z plus tan y minus 3z. So, we will discuss how to use grouping method to solve the given linear P.D.E. So, the general Lagrange equation is given by P plus Q is equals to R. So when the equation is in this format, you can use grouping method to solve. You form auxiliary a system of equation such that dx all over p is equals to dy all over q is equals to dz all over r. So from the given equation, you can write it in this form: ZP plus 0q is equals to minus x. You identify P, Q, and R. Your P automatically is equals to Z, Q is equals to 0, and R is equals to minus x. So, and R is equals to minus x. Writing it in auxiliary form, dx divided by p z is equals to dy all over 0 is equals to dz all over minus x. Then after this, you pick a set of functions which will cancel each other. Like you pick this and that, this and that, that and that, whichever form. Regardless, they cancel each other and you will be able to integrate them. So pick this and that. dx all over z is equals to dy all over 0. So in this form, you multiply 0 on both sides. So 0 is equals to dy. This now is integrable. You use direct integration. So the integral of 0, the integral of a constant, like 1 with respect to y is equals to y, which is equals to c1. And this is equivalent to u primitive of x, y, z. Again, select another form of fractions that will cancel each other and they are directly integrable. Like select this and that, you have dx all over z is equals to dz all over minus x. So if you multiply both sides by x and both sides by z, so x dx is equals to minus z dz. So in this form, it is easier now to integrate. So x dx plus, you bring z dz on the other side is equals to 0. Using direct integration, you have integral of x dx plus z dz integral is equals to 0 is equals to constant of integration c2. So x squared over 2 plus z squared over 2 is equals to c2 is equals to c2. Multiply both sides by 2. X squared plus y squared is equals to 2c2. But note that 2c2, c2 is constant. A number multiplied by a constant is always constant c2. So x squared plus y squared is equals to c2. This is phi. Function of x, y, z is equals to x squared plus y squared. The general solution now of the above linear P.D.E will be given by u v is not equal to 0. So your final answer will be u, which was y, v, x squared plus y squared, which is not equal to 0. Example 2. P tan x plus q tan y is equals to tan z. Again, written in standard form in form of p. It's written in form of pp plus qq is equals to r. So it is simpler to identify the value of p. To identify p, which is tan x, q tan y, and r tan z. In auxiliary form, the P.D.E will be dx all over tan x is equals to dy all over tan y is equals to dz all over tan z. So you select two fractions which will cancel each other, or they will be integrable. Like directly you can select this and that. Dx all over tan x is equals to dy all over tan y. So 1 over tan x is equivalent to cot x dx is equals to cot y dy. So 1 over tan is equals to cot. Remember that. And the integral of cot, so you directly integrate, it will be integral of cot x dx minus integral of cot y dy is equals to c1. Is equals to c1. The integral of cot x from table is natural log of sin x minus the integral of cot y, which is natural log of sin y. The integral of cot x dx minus cot y dy is equals to c1. So from our table, the integral of cot is natural log of sin x minus natural log of sin y is equals to natural of c1. So using the law of logarithm, you factor out natural log sin x minus become divide sin y is equals to ln of c. C1. ln and ln cancel. So sin x over sin y is equals to C1, which is equivalent to u function of x, y, z. U function of. So first you have picked this and that. Now you can pick this and that for you to find the value of v. So cot y dy is equals to cot z dz. You bring cot z on the other side, cot y dy minus cot z dz, which is equals to 0, implying that you integrate on both sides, and the integral of cot y dy minus integral of cot z dz is equals to 0. So remember, we have said that the integral of cot is natural log of sine minus natural log of sine z is equals to natural log of C2, where C2 is your constant of integration. So sine y all over sine z is equals to C2, implying that the general solution is given by uv. Primitive of uv, and your u was sine x all over sine y, all over sine z, which is not equivalent to 0.